In this question, we will determine the moment of a couple in a three-dimensional setting. Determine the couple moment acting on the pipe segment AB is directed 30 degrees below the XY plane. In this question, we can see that there are two couple forces, 25 newtons here at point B acting in the positive Z direction, and another 25 newton force acting downward in the negative Z direction. There is a certain perpendicular distance separating the two couple forces, and this can easily be found. So therefore, the very first method that we will use is a scalar method, since we can easily find such a perpendicular distance. Method 1, a pure scalar method. In this case, the moment due to the couple forces is simply equal to the magnitude of one of the forces multiplied by the perpendicular distance d, where the force here is just 25 newtons multiplied by the perpendicular distance. According to this right hand side figure here, the perpendicular distance is actually referring to this distance here, right? This horizontal distance here, which can be easily found by 0.6, which is the length of this segment AB, cosine 30 degrees. And that will give us 13.0 Newton meter. So to put this into a vector form, we say that the moment is equal to minus 13.0 J Newton meter. Why is it J? Because you look carefully, the direction of this couple moment is actually according to your right hand rule. Your fingers curl in the direction of rotations of the couple forces. Your thumb will point in the negative Y direction. Therefore, it's negative J here. The second method that we will use is a vector method. We can actually take moments about any point that lies on any of these two vectors. So if we choose to take moments about point A, then obviously this couple force here pointing in the negative Z direction will disappear because there's no moment arm. So we take moments about point A. In this case, the moment is solely due to this 25 Newton couple force acting at point B. So M is equal to summation of moments about A. In this case, is just equal to the vector RAB cross 25K. RAB is actually referring to this vector pointing from A to B, and 25K is obviously referring to this couple force here. So in this case, it's just equal to the vector RAB, which is in the x direction 0.6 cosine 30 degrees I, because if you look carefully, it travels by this distance in the x direction, which is just 0.6 cosine theta, cosine 30 degrees, minus 0.6 sine 30 degrees k. There is no displacement in the y direction, but however, there is a downward displacement in the z direction by a distance of 0.6 sine 30 degrees. And of course, we have to cross it with 25K. And this will give us minus 13.0 J Newton meter. That is because K cross with K is obviously 0. I cross with K is minus J. And this number multiplied by 25 will give you 13.0. As mentioned, we can take moments about any point that lies on any of these two couple forces. So just now we have taken moment about point A. Now we try to take moments about point B. So if we were to take moments about point B, this 25 Newton force pointing in the positive Z direction will disappear because the moment arm is 0. In this case, M is equal to summation of moments about point B, which is equal to R B A, Right, RBA is the vector pointing from B to A because you are taking moments about point B. So the vector should originate from point B. Cross, the force here is a 25 Newton force pointing in the negative z direction, therefore it is minus 25k. So in this case, RBA is moving in the negative x direction by 0.6 cosine 30 degrees. So minus 0.6 cosine 30 degrees. I, in the j direction, it is not moving, but in the k direction, it is moving upwards by 0.6 sine 30 degrees. Okay, and then you have to cross by your force, which is minus 25k. So that will give you k cross k give you 0, obviously. I cross k give you minus j, and this minus multiplied by this minus is becomes positive, so we end up with just minus 13.0 j Newton meter. Same answer as previously. In the final method, we can take moments about any point actually on the rigid body. Now in methods 2 and 3, we took moments about point A and B respectively because we wanted to eliminate one of the couple forces, leading to a simplified solution. But in reality, we can take moments about any point on the rigid body. So in this case, we take moments about point O, M, once again, summation of moments about point O, which is in this case, we have two position vectors shown by this yellow vector here, ROB, which is the vector pointing from O to B, and ROA pointing from O to A. So in this case, it is equal to ROB cross the positive 25 Newton force, which is 25k, plus ROA cross the negative 25 Newton force, minus 25k. So we diligently find out the vector forms of the two position vectors and perform the cross products. For ROB is 0.6 cosine 30 degrees I, because in the x direction it is moving actually by this distance, right, which is 0.6 cosine 30 degrees. In the j direction, it is also moving by this distance, 0.8 meters, so plus 0.8 j. And finally, in the z direction, it is moving downwards by 0.6 sine 30 degrees minus 0.6 sine 30 degrees k cross 25k. And then for the other case, ROA, in the x direction is not moving at all. In the y direction is moving by 0.8 j plus 0.8 j. In the z direction, it is also not moving, so we just have 0.8 j cross minus 25k. And now let's perform the cross products. K cross k will give you 0. I cross k gives us minus j, so we have minus 13 j, where 13 is just this number here multiplied by 25. J cross k gives us I, so plus 0.8 times 25 is actually 20i. And then finally is j cross k, which is just I, and then there's a minus sign here, so it's minus 20i. So in the end, this will give us minus 13.0 j Newton meter. Let's go through another example. Express the moment of the couple acting on the rod in Cartesian vector form and find out the magnitude of the couple moment. So shown on the left, we have a pair of couple forces that form a couple. The force minus F, the x at point A, and the force F, the x at point B. If we know the perpendicular distance that separates these two parallel forces, then we can easily find out the couple moment using a scalar analysis. But in this case, it's not easy to find out this perpendicular distance, and we will have to resort to a vector analysis. So what we do is that we take moments about point B. So we take moments about point B, which means that the contribution to the couple moment due to this force is 0 because the moment arm is 0. So couple moment is summation of all moments about point B, which is in this case RBA cross minus F, where RBA is the vector pointing from B to A, and of course the force minus F is this force here. Alright, as mentioned, there's no contribution due to this force F because it cuts through the point B. So we can express this cross product as a determinant I, J, K. Now for the vector RBA, it is moving in the negative x direction by 3 units. So it's minus 3, and in the y direction, it is moving backwards by 2 units. So it's minus 2. In the k direction, it is moving upwards by 1 unit plus 1 more unit here. So it's 2 units. Now for the force minus F, the vector is given here, 4, minus 3, and 4. To compute this cross product, we can use our Casio calculator. So we choose menu, go to vector option, and then define our vector A. Dimension is 3. First element is minus 3. Second element minus 2. Third element is 2. And option, define our vector again. This time is vector B. 3 again. First element is 4. Second element is minus 3. Third element is 4. And then you go to option and vector calculation, and we choose vector A cross option vector B. That will give us minus 2, 20, 17 as the cross product, equal minus 2i plus 20j plus 17k kilo Newton meter. To compute the magnitude of this couple moment, we make use of our property from the study of vector analysis, the square root of the couple moment not by itself. So using the calculator, go to option, choose vector answer, which is the last answer, which is the couple moment, and then go to option, dot product, and go back to option again, and select the vector answer, and then remember we have to square root this dot product and put a closing bracket. So the magnitude of the couple moment is 26.3, equal to 26.3 kilo Newton meter. So in this lesson, we have learned how to compute the moment of a couple in 3D. Now, in the previous example, I've illustrated several methods of computing the couple moment. Depending on the situation, if you know the perpendicular distance between the two couple forces, then you can easily resort to using a scalar analysis. But if you do not know such a perpendicular distance, then you have to resort to using a vector analysis. And in that case, it is easier to take the moments about a point that lies on the line of action of one of the couple forces. For example, in this case, either point A or point B, so that we can eliminate one of the forces when taking moments about the point. Hope you enjoyed the lesson, and we'll see you next lesson.